In partnership with other global space agencies, ESA is preparing to expand human presence in the solar system. As a first step, a base supporting human exploration of the Moon is envisaged. Future space exploration missions will last months or even years. One problem that must be solved early is how to supply the consumables and spare parts needed to enable these long-duration missions. Imagine an astronaut exploring a lunar crater on a rover. Suddenly, a wheel suspension unit on the rover breaks. The options are limited. There is no breakdown service on the Moon. What's the best way to fix the rover and enable the exploration mission to be continued? One solution is to manufacture replacement parts on the Moon instead of transporting them there. The ESA study SMARTIE presents a realistic solution. The study proposes the creation of an autonomous Internet of manufacturing things. This computer-based network would support a sustainable lunar base by carefully managing resources and needed items for the crew on a daily basis and forecasting the maintenance for an efficient logistics plan. It would be helped by additive manufacturing technologies. With embedded IoT sensor networks and control systems, equipment and machines can be interconnected throughout the lunar base to a data cloud. The data cloud is connected to a lunar satellite network as envisioned in ESA's Moonlight. Manufacturing data, if captured and analyzed for insights, can help astronauts identify operational bottlenecks and improve productivity. With the help of this data, local resource utilization and material recycling process requirements can be predicted and the base infrastructure maintained efficiently. A mirror cloud is established on Earth to ensure that selected parts can be supplied from Earth if needed. Initially, Earth-based logistics will be needed. Later, when more people are on the Moon, missions last longer, and the lunar surface infrastructure has been established, a local production capability using in-situ resources will be essential. The goal is to establish an autonomous and sustainable large lunar base. Ultimately, human exploration of Mars and the solar system will not be possible without an expandable IOMT architecture. Such system architecture with hardware and software components requires little mass and is thus cost-efficient to install. It will tremendously improve the astronauts' operations. And IOMT development will bring lasting benefits to everyday life on Earth.